Hi, pre-calc. Sorry about that. I am back, and right before I had shown you the smiley face up with this hot pink was your concave up, and then I was just going to say halfway between your minimum here, there's your min, and your max is where it starts to go concave down again. And so I'm going to grab that purple and do my concave down. So my concave down would be from here on, okay? So you can kind of see how it goes concave down, concave up for just a minute, and then concave down again. I do also want to show you that notice that this right here is halfway between the maximum here and the minimum right here. That would be considered a point of inflection. And halfway between here, and again, the point of inflection is where concavity changes. So it's going from being concave down along here to concave up at this point of inflection, and then it goes from concave up to concave down at this point of inflection. Okay, so you can kind of see where all this is. So now let's go back and try and answer our questions. The graph is concave down. So we said concave down was that purple. So it's concave down from D, and I'm going to label my point of inflection K here and M here. So we could follow that down. K. That's just the X value of the point, right? It would have a different Y value, but I labeled them up there so we could follow them down. So from D to K, we have concave down, and from M to infinity, we have concave down. That's if we're going to assume that that goes to infinity. The graph is concave up from K to M. And then relative max values at. See, the values are the Y values, and they haven't given us any Y values here, right? They didn't follow over and give us any Y values. So that's why they say at. So they are just going to say, we're just going to tell them what X values they're at. So my relative maximum would be at E. So I'm going to say X equals E. And I've got another relative maximum at G. X equals G. And then a relative minimum at F. X equals F. Now remember, those are not the actual maxes and mins. It would be the Y value at that point, at these X values, okay? But since they said at here, I knew we could just say this is where it's happening, at these X values. All right, so I want to do this example number 6 because this was the end of our notes, okay? But of course, there were a few examples that were added, and actually they were all good, but you don't absolutely need them yet. But I'm going to do this one with you. So it says, for the given polynomial f of x equals 0.5 times x plus 2 times x minus 3 cubed. Part A, list each real zero and its multiplicity. And for part B, oops, sorry. Oh my. State whether it crosses or touches the x-axis at the zeros. Okay, and part C, state the maximum number of turning points. Do you see why I want to do this example? This is all the stuff that we had defined and we have not been able to do yet, okay? So when I put this function in my calculator, I'm going to see a graph of it, okay? So 0.5 parenthesis, x plus 2, close the parenthesis, open another parenthesis, x minus 3, close the parenthesis, caret 3, because we want that one to the third power. And I'm going to hit zoom 6 to get back to my normal graphing mode. But I then see that, oh, I'm going to need more of my y values for that graphing mode. And so I'm going to go ahead and change my window. I want to go down to, let's say, negative, or actually, you can leave the x's alone or even make them smaller if you wanted to, but the y's, you need to go down to negative 35 and go up to positive 35. Why not? I don't know. And hit graph. It kind of gives you a better idea of the graph when you do that. So I'm just going to sketch it, a rough sketch of it here. It comes down, it comes down and kind of goes like this and goes like that and goes up like that. Minus that little part. Oh, it erased the whole thing. I'm sorry. Okay. So it kind of flattens out here because that's that third power, right? That x minus 3, so this is at x equals 3. And this one's at negative 2. That 0 is at negative 2. So when it says list each real zero and its multiplicity, we're going to say zeros. We're going to say multiplicity. And we're going to say behavior. And we've got x equals negative 2. And its multiplicity is 1 because it's to the first power up here. And so the behavior is cross. And then we have x equals 3. Its multiplicity is 3. And its behavior is cross. So when it said list the real zero and the multiplicity, this part is A. Then it says state whether it crosses or touches the x-axis at the zeros. That's actually B right here. So A and B are in this one chart together. Okay. And then state the maximum number of turning points. Well, this is an x to the first times an x to the third, so that's an x to the fourth. So we have a degree 4. And so it's going to have 4 minus 1 turning points. Remember, if your degree is n, it has n minus 1 turning points. Or it's going to have at most, I should say. Now, when I did this graph, I calculated my minimum here. And my minimum, can't see, my light went off. My minimum was negative 0.750, comma, negative 32.959. And then that 0 where it flattens out, that's a point of inflection, right? Where concavity changes. So you can see that it's concave up. I'm going to go ahead and maybe use this. There's your concave up. And how about orange for concave down? But then about right there, we've got concave up again. Okay. The reason I wanted you to pay attention to that is because I wanted us to practice calculating the point of inflection, okay? Because this point of inflection right here, where concavity changes, it goes from being concave up to concave down and then goes back to concave up again. This is going to be in between the 0.30 and negative 0.750, comma, negative 32.959, right? Because this one was your, this is actually your absolute min for this particular function, right? Because look, it goes to infinity on both sides, so this is the lowest y value. Negative 32.959 is your lowest y value. So if I had to say what the range of this function was, it would be negative 32.959 to infinity, because that's my lowest y value. And all the other y values, you know, from that point on up are being used. But now to calculate this, because part D that I did not write down says state the intervals where the function is concave up or concave down. So they want us to state those intervals and approximate your point of inflection. And I think it was worded maybe a little bit differently than that. It might have said, you know, approximate whatever, the point of inflection if you think there is one or something like that. Okay, so we're going to say concave up. From negative infinity to, we need that point of inflection, don't we? Because it's concave up to the x value of this point of inflection. So whatever this x value is, negative infinity to that x value, because this is our point of inflection here, it'll be from that x value, or negative infinity to that x value. So let's calculate our point of inflection. We are going to add our x's, 3, and since adding a negative is minus, divided by 2, and then we're going to add our y's. And divide by 2. And so this one's going to give me 1.125, comma, negative 16.5. So this point of inflection, 1.125, comma, negative 16.5. We are going to be using, because it's going to be concave up from negative infinity to this x value, which happens to be your 1.125. It's also concave up from 3 to infinity. Concave down is from 1.125 to 3. And it's in orange there, so you can see it. And point of inflection is approximately 1.125, negative 16.5. Okay? And so I did want to show you that. The other two examples that they gave us, I thought were pretty good, but they were having you use a graphing calculator on one of them. This example number 4, you definitely had to use a graphing calculator. On example number 7, if you took notes, it also asked you to use a graphing calculator and basically analyze a function. So I don't know. I'm not going to worry about it. I think this is enough. I did want you to add this example because I thought it really will help you understand about turning points and, you know, crossing and touching and multiplicity and zeros and how to calculate an approximate point of inflection and things like that. So hopefully this helped.